Hello friends, this is my 20th lecture in Signal System series. My name is Nishtha Verma. The topic which I am going to cover in this lecture will be the properties of Fourier transform and the numerical based on it. First property is time shifting property. We know that if xt is there, its Fourier transform will be x j omega, and if xt minus t naught means time shifting is there, then exponential term will get multiplied with Fourier transform exponential term with same sign. If minus t naught is there, so minus j omega t naught will come over here, then x j omega. Frequency shifting, if xt is there, its Fourier transform is x j omega, and if frequency shifting means exponential term is present at the input side xt e to the power j omega naught t, then there will be a frequency shift omega minus omega naught, but the point should be remember that here positive sign with omega naught, here negative sign will come. Means in time shifting the same sign comes, while in frequency shifting opposite sign comes. Now suppose we have to find the Fourier transform using property. Here xt is equal to delta t minus 2 is there. We know that in last lecture we did that delta t Fourier transform is nothing but 1. So here time shifting is there. So we know that if time shifting is there, then exponential term will come with same sign minus j2 omega, and delta t Fourier transform is 1. So this will be the Fourier transform of delta t minus 2. In the same way we have to find it. So what we will do, e to the power minus 2j omega multiplied by 1, as the Fourier transform of delta t is 1, plus e to the power, because positive sign is there, 2j omega multiplied by 1. So final Fourier transform will be e minus 2j omega plus e to the power 2j omega. Now next is xt is equal to ut plus 2 minus ut minus 2. If you remember, Fourier transform of ut is equal to nothing but pi delta omega plus 1 by j omega. We did the derivation of this ut in last lecture. So here we are going to directly use the result. So here exponential, because time shifting is there, so time shifting with same sign will come, e to the power 2j omega multiplied by ut Fourier transform is pi delta omega plus 1 by j omega. In the same way minus e to the power minus 2j omega multiplied by pi delta omega plus 1 by j omega. When we open the bracket, we will see that 2j omega multiplied by pi delta omega plus e to the power 2j omega, j omega in denominator, minus e minus 2j omega pi delta omega minus e minus 2j omega j omega. So because here delta omega is multiplied by e to the power 2j omega, if you remember the sampling property, because here 0 shifting is there, so 0 will come here, e to the power 0 will be 1. So this term will become pi delta omega plus e to the power 2j omega j omega. This term again using sampling property, when omega equal to 0 you will put, it will become 1. So pi delta omega minus e minus 2j omega by j omega. So same term will cancelled out, and 1 by omega we can take common. We know that e to the power 2j omega minus e minus 2j omega, if we multiplied by 2 and j is already there, so it becomes sine term. So it becomes 2 by omega sine 2 omega. So this will be the final result. Now xt is equal to e minus a t minus 2 ut minus 2. Here we can see that time shifting is there. So in time shifting, exponential term with same sign comes, means minus 2j omega will come. And we also know that the Fourier transform of e minus at ut. To find the Fourier transform, we should remember that the limits will be from 0 to infinity. E minus at e minus j omega t dt, and its Fourier transform is nothing but, when we integrate it, we will get a plus j omega. So here it will come e minus 2j omega, in denominator a plus j omega. This will be the final answer. Now next is xt e minus 3t ut minus 1. You should always remember that if time shifting is there, the time shifting should be with all the t terms. But here we can see that t minus 1 is missing. It means its value should be e minus 3 t minus 1 multiplied by ut minus 1. So when we take the Fourier transform, we know that time shifting is there. T minus 1 means e minus j omega. So here, because only this term is minus 3t is given, so we can say that e to the power e minus j omega divided by e to the power 3 will come here. Then Fourier transform of e minus 3t ut. So if we find the Fourier transform of this function, we will get e minus j omega. If we take it in the numerator, it becomes minus 3, and its value will be j omega plus 3. So final result will be minus, we can take common, j omega plus 3, in denominator j omega plus 3 will come. Now next is xt e to the power j omega naught t. So this is our frequency shifting property. We know that we can assume that 1 is multiplied over here, and the Fourier transform of 1 is nothing but, one Fourier transform is 2 pi delta omega. So 2 pi delta omega minus omega naught, because opposite sign comes in case of frequency shifting. So answer will be this one. If cos omega naught t is there, so here what we will do, we will change it into exponential function. It will become 2 to the power j omega naught t plus e minus j omega naught t by 2. So as 1 is multiplied with all the functions, so we can say that 1 by 2, Fourier transform is 2 pi delta omega minus omega naught plus 2 pi delta omega plus omega naught. When we open the bracket, 2 will cancel out. We will get pi delta omega minus omega naught plus pi delta omega plus omega naught. So this will be the final answer. Now e to the power j omega naught t ut. Here frequency shifting is there with ut. We know that ut Fourier transform is pi delta omega plus 1 by j omega. So when we do the frequency shifting, so it will become pi delta omega minus omega naught plus 1 by j omega minus omega naught. So this will be the final answer. Now here xt ut plus 2 minus ut minus 2 cos 3t. So first of all, what we will do, we will try to plot ut plus 2 and ut minus 2. It will become a pulse. So here it is minus 2, it is plus 2, and the magnitude is 1. So the Fourier transform of this function will be from minus 2 to 2, 1 e to the power minus j omega t dt. So when we integrate it, we will get e to the power j omega t, in the denominator minus j omega, with limit minus 2 to 2. So here 1 up j omega e to the power minus 2j omega minus e to the power, it become minus, minus will become plus 2j omega. So when we use a formula, we know that sine formula. So if we take minus common, it will become 1 by omega, 2 multiplied, it become e to the power 2j omega minus e minus 2j omega by 2j. So now it will become 2 by omega sine 2 omega. So as cos 3t is there, if we change it into exponential function, it will become e to the power j 3t plus e minus j 3t by 2. So we can see that using frequency shifting, it become 2 by omega minus 3 sine 2 omega minus 3, and for this one, this term 2 will be cancelled out. It will plus, when we multiply it here, sine 2 omega plus 3 upon omega plus 3. So this will be the final answer. If you like my video, please subscribe my channel. Thank you.